All right, guys. I hope everyone had enjoyed the 3-day weekend. I know most of the days feel like 3-day weekend, but the family time is what counts, right? So let's go ahead and begin. So today we're gonna go ahead and work with models. So pretty much applications, reading a word problem, finding out what it is. So specifically exponential models is what I want to go ahead and focus on, but they're not that bad. Let's go ahead and think about this right here. So with respect to time, right? Instead of x, but with respect to t, since most of the exponential models are something that goes along with time, so something growing exponentially with time, or something growing really, really small with time. So if we were to go ahead and differentiate this right here, we would see that there's the same thing as saying dy, and I said it was with respect to t, so dy dt is equal to ky. Okay, where k is the coefficient of proportionality, and then we're going to go ahead and do the same thing as we did the previous week, where we go ahead and separate the variables. So this y, I'm going to go ahead and move it to the other side, and this t, I'm move it to the other side. So this y, to get rid of it, I'm going to multiply by 1 over y, I'm going to multiply by 1 over y, and this dt, I'm going to multiply by dt. So I should see that this right here, this y and this dy are inverses, so that I can get rid of them. So I should have 1 over y dy is equal to k dt. So far, so good. Okay, just like we did last week, we're going to go ahead and integrate both sides. Integrate both sides. And we should be able to get the integral of 1 over y. That one is it should be all right by now. We've been doing a lot of integration with exponentials and ln's. So this should be ln of y is equal to the integral of this. Ooh, that looks hard. But keep in mind, what is my variable that I'm working with? Well, it is t, right? So I don't see anything here. I should assume there is a 1 right here. So if I integrate 1, what should I have? I should just have t times whatever this was right here, this k. Don't forget your c. Any questions so far? Okay. Last but not least, I am solving for y, but it is with an ln. So hopefully we still remember how to get rid of the ln's. We put everything to be the exponent, both left and right. T times k plus c. And we do this in order for our ln and our e's to go ahead and simplify, right? So I got y equals, here's the part that's going to be a little confusing. I got e t to the times k, and then I got addition of c. Well, remember, in order to add exponents, an times a m is n plus m. So I can break this up right here, this addition, if I remember that this is just multiplication of the same base. Okay. So you're probably thinking, well, why did I do that? Well, this is very, very similar to our homeworks. No matter what I do to this, this c, whether I multiply it, add it, subtract it, divide it, no matter what I do to it, it's still going to be c. So all of this right here is the same thing as saying y equals e t times k, and this e to the c, no matter what it is, it's still a number, it's still c, so times c. So our answer should be y equals c e t k. So this is what we're going to be learning today, this formula right here. So I know the book just gives it to you, but I feel like we should know at least where it comes from. So this is what we're going to be using. Any questions so far? Okay. So give me a couple more seconds and then we'll continue. Alrighty. Oopsie daisy, what did I do here? Oh, I put transitions. Sorry guys, I was messing around with it. I forgot to take them off. Okay, so pretty much this is just a breakdown. So exponents can be known as two things, something either growing exponentially or decaying. So growth, that should be something increasing like that. And when our exponent is decaying, it is ending, it's eventually reaching some asymptote, right? And this one is exploding up from the asymptote. So in order to use these, they will either say the word growing exponentially or you will see a graph. So keep in mind, you don't have to do it always, but when it does say that, we'll be using that. So pretty much broke it down, just in case so we could remember. This is your variables. This with respect to time. And this is proportional to k, and k is our constant of proportionality. So rate of change, guys, whenever you see rate of change, it's just a dy over the whatever is respect to. Most of these are time, though. Okay, so this was on the notes. I do have that formula in the next slide as well. So this is what we derived. So pretty much from that last equation, we were able to do it. C, we can find C with the initial values. Usually when something is starting, time is 0. That's how initial value works. And that's how we solve for C. K is how fast something is growing. So if it's a positive number, it's going to be increasing. And if it's less than between 0 and 1, then it is going to be decaying. It's going to be decreasing. Okay. I'm sorry, fraction. Sorry, negative number. When k is negative, then it will be decreasing. Sorry about that. T is time, k is rate, E is a number, and C is the value we can find by the initial condition. So how much stuff there was at the beginning. Okay. All right, so let's go ahead and do one example. These aren't that bad, I promise you. So.
Can you go back? You're going a little too fast.
Oh, sure. So this was the differential equation. And once we integrate it, we got this, right? Just to confirm that we know where this came from. So whenever we're working with exponential growth, exponential decay, we'll be using this one. So you don't have to integrate every single time. You can automatically do that. Okay. Alrighty, can I continue this? Albert? And I do
Yes, sir.
post these before time, so you guys can write the notes since I know it's a lot of writing. Okay, so pretty much the rate is y is proportion. I'm sorry, the rate of change. So y prime is proportional to y. So pretty much what we just said right here, right? So our y prime equals ky, just like we did, oops, what am I doing? Just like we did before, right? dy equals this. But I don't want to integrate every single time, so I'm going to use what I just learned right here, right? So dy prime equals ky. Okay, so automatically I should be thinking of y equals c times my ekt. Yes, because this is from the equation from the do now that told us that we always use this one because of the theorem. So far, so good. Okay. All right, so this is all I know so far up to here. Now, the next thing that they're telling us is t0 y equals 2. So I'm going to go ahead and write that somewhere. So when t equals 0, my y equals 2. If I wanted to put it in coordinates, I can go ahead and say 0 and 2. Now, some of us might be wondering why I put the t to be my x's and the y's to be my y's. Well, remember, according to this, you are doing dy dt. So remember, you with respect to your t's. So this is your inputs. This is your dependent. This is your outputs. That's how I knew which one was my x. Okay, and then we have the next value that says when t equals 2, my y equals 4. Okay. All right, so let's go ahead and find, so let's go ahead and do this real quick. So we want to use the equation for this right here. And I want to find what is C. So let's do that. Let's see, get a marker. So I'm going to substitute what I know. So I'm going to use what I know. The first initial condition was when t equals 0, y equals 2. So according to this, t equals 0. So I'm going to put this right here, and my y equals 2. I'm going to go ahead and put that right here. So I got 2 equals c times the exponential k times my t, which is 0. Easy peasy, 2 equals c e. K times 0 is just 0. And any number, right? Any number to the 0 is equal to 1, right? So I got 2 equals c times 1. So therefore, c is equal to, whoa, struggling here. C is equal to 2, right? C is equal to 2. Now, the next thing you want to do is find K. Now that we will use the second part that they gave us. They said that t is equal to 2, so I'm going to use my value 2 and my y is equal to 4. Back into the equation with the c. So let me substitute what I know as of right now. So I know y is equal to, right? This was the equation that we are using. But now I know 2. Y is equal to 2 e k t. I'm going to go ahead and pause since I know this might be a little tricky for us. All I did, guys, was I found C and I put it back into my equation right here. That's how I got this right here. And now I'm going to go ahead and substitute my next point. I'm going to go ahead and substitute 2 and 4, where this is my T, this is my Y. So 2 goes right here and my Y go right here. So I got 4 equals 2 E K, oops, that looks like a 1. K, and my t is equal to 2. And I'm just going to go ahead and solve for this. Struggling here. Okay. So first thing first is 2 right here. I can go ahead and simplify, divide by 2, divide by 2. I got 2 equals EK2. Hopefully you're brainstorming on what we can do next. How do I get rid of the value? I'm solving for k right here, but it is on the exponent. So you should be hoping to use natural logs. Natural log e k2. And that goes and gives us the following. Ln of 2 is equal to, well, ln and e are inverses, so I can get rid of them. So all I'm left with is k2. And we can solve for this. Divide by 2, divided by 2. K is equal to ln 2 divided by 2. Very, very careful, guys. Notice that I cannot simplify the 2's in there, right? So let me highlight my answer. It's right here. So I should have an answer right here. So far I have this so far that the differential equation will be y equals c. I already know my c, which was 2. E I know is a number. K, well, k is this right here. So it's going to be ln 2. And I'm going to write it as a fraction, so 1/2 ln 2 times my variable t. That's really messy, I'm sorry, guys. Just notice that everything here is on the exponent. All of this is the exponent. Now we have the exact equation for this right here. So what we're going to go ahead and do is that the final part of the question says, hey, I want you to find out what y is when t equals 3. So we have the differential equation. It's this one right here. We want to find y when t equals 3. So not that bad, guys. All we're going to do is substitute this right here to find our value. So it's y equals 2e 1/2 ln 2 and times 3. Okay. Ideally, guys, this is an acceptable answer. I just want to go ahead and simplify the best I can. Right here, this ln and this e, since that's not going to cost a lot to do, right? So this is the same thing as saying y equals 2e, and this right here, I'm going to go ahead and modify this 1/2 to go ahead and be, sorry, the exponent of just the 2. So it's going to be ln 2 1/2. And this right here, guys, is being multiplied. So hopefully remember that the only way you can multiply, multiply in the exponent is when you have something raised to each other. So this right here, you could have said it is being also multiplied by 3. So it's y equals to e ln, the e and the ln are exponents, sorry. And then all of this was 3/2. So we can get rid of that. So our answer is y equals 2 to 3/2.
There, that's my hand.
Another way to see this, guys, is that you could have multiplied the 3 right here and the 1/2, and that would have been a lot easier. And I just saw that right now, since both of these are in the values. So this is your answer.
What you did.
So ideally, this could have been an acceptable answer. I just wanted to go ahead and simplify using the exponent rules. Any questions so far? So to tie it back to this problem, 2 times 2, 3/2 would be the y value when this is happening right here. This would be 2, 2, 3/2 is that value right there. Any questions so far? I know this is very, very, very messy. If you do have questions, guys, go ahead and unmute yourself and I can try to answer the best I can. Or in the chat box, either one will work. Yes, yes, you can even more, but for the purpose of this, you're good. I know you can go ahead and say that this is same base, so you can say it's 2 2's plus 3/2 to 5/2 as that, if you wanted to.
Oh my gosh. I'm all messing up my string.
I wonder
Yeah,
if
but-
there's a shortcut for all this work.
Calculator. You could have just put all of this in the calculator, definitely. Okay, any questions? I guess the point is this right here, guys. You need to find C, find K, and find the differential equation. And then they'll give you some point. In this case, our point was t equals 3. All right, let's go with the next one. Okay. Sorry, I'm struggling here. That's not going away. Okay, sorry about that. Alrighty, the next one, and this one's not specifically rate of change, but this one is still this is still a model. So it says the rate of change of n bears. So dn in the population is directly proportional to this with respect to time. So dn over dt. Hopefully you were able to get that as well. dn over dt. So the population of bears is directly proportional, right? It's directly proportional, so it equals this right here, 350 minus n. Okay, now we are missing one tiny thing. Hopefully you guys can remember that. We're missing that there is a constant of proportionality. This is from our 7.1 lesson, 7.1, where we used the K. So if you forgot about how to set these up, guys, these are 7.1 lesson. Okay. All right. The next thing that we're going to go ahead and do is the same procedure. We want to separate the variables, integrate, just like how we did in the 7.6 is 7.8 homework. Sorry, 7.7. Sorry about that. Okay. And then we can use these initial values that we are learning from today. So remember, first step is separate variables. So that's what I'm going to go ahead and do. I'm going to move all the ends to the same side. All the ends to the same side. So this one has an n. So it's going to be, move all of this right here, I'm going to go ahead and divide. So I'm going to divide both sides by 350 minus n. Divide both sides, 350 minus n. And I'm going to move this dt to the other side. So it's going to be 1 over 350 minus n dn equals k, right? Because it's all of this canceled. I mean, simplified dt. Okay, so I have everything separated, and then we remember that we need to go ahead and integrate. Second is integrate with respect to t, right? With respect to t. So I'm going to integrate. I'm going to integrate. So all of this one's going to be a little tricky because my numbers are in the denominator, right? So hopefully this doesn't mess you up. This is u substitution. So u is 350 minus n. Du is -1. But I don't see a -1 here anywhere on the left-hand side. So that means I need to go ahead and compensate for that. So I'm going to multiply by a negative du. So I'm going to integrating 1 over u with the little negative because of that value. Every time we have the denominator on 1 over u, that is ln, so negative ln of u, and we said u was this right here, 350 minus n equals, well, we need to integrate the right hand side. I only have a 1 here because of the coefficient. So if I integrate 1, I should have just t multiplied by that constant k plus c. So this is t k plus c. Okay. I like having everything as best as I can. So I'm going to get this negative right here. And I'm going to divide everything by a negative to make this nicer. So it's going to be ln 350 minus n equals negative tk. Now this c, guys, I don't know what the number is. I don't know if it's negative. I don't know if it's positive. So if I go ahead and multiply it by a negative, multiply it by a positive, I'm just going to leave it as a positive c, no matter what. So c times a -1 is still c, regardless of the sign. So that's why this c did not get affected when this positive got multiplied by this negative. So I found this equation right here. Okay. Now I can go ahead and do from today's lesson, which is our 7.8. And it says find C using initial point. In this case, the initial point is this right here. They told us that this highlighter, that when t equals 0, the population is 100. So when t equals 0, the population is 100. AKA, this is t and this is n. Okay, so the equation that I have is this one. Let me highlight it. This is what I have so far. This is what I'm going to use to go ahead and find my C value, given this initial condition. So let's go ahead and substitute what we know. So it's going to be the following. ln 350 minus my n. What did we say our n was? This right here. Our n is
100.
Yep, 100 equals negative t. Do I know my t? Of course I do. It was the initial, so it should be 0 times my k plus my c, right? All I did was substitute this equation right here into this right here. So we go ahead and simplify everything. ln 350 minus 100, that's 250, equals 0 times k, well that's 0, so our c should be just this right here. Any questions so far? So this is my C value. Yes, no? So let me write what I have. So far I have this. The equation is ln 350 minus n equals negative tk plus my c, but I found out my c was ln of 250. This is what I know so far. Okay, so I'll wait a little bit just in case we need to catch up. And our last step will be finding k. So will we find k given the next value, which according to this is when t equals 2, it has increased to 250. So our next point is going to be using t equals 2, n equals 250. And that's what we're doing, guys. We're just substituting. So let's go ahead and say this is my t and this is my n, because that's what the question said. Time is 2. Total amount of bears is 250. So I'm going to substitute. So it's going to be ln 350 minus 250 equals my t value. Oh, now this time it is 2, so negative 2k plus my ln of 250, because that was my c that I had just found. Okay, so let's simplify. We got ln 350 plus, minus 250, that is 100, is equal to negative 2k plus ln of 250. All you're doing, guys, is combining like terms. So let me move this minus ln of 250 minus this ln of 250. So this right here, I'm going to go ahead and say it's division, right? Because subtractions of logs is division. So ln 100 divided by 250 is equal to negative 2k. I don't know about you guys, but that 100 and that 250 I can simplify, right? The little zero trick, right?
What?
What part did I lose, you, Albert?
You divide 100 and 250? What?
Yeah, subtraction of logs is division. That's a rule in exponentials. I mean, sorry, logarithms. Yes,
Okay.
no. And then I'm going to reduce it to a fraction right here. So I can divide by 5, right? 10 divided by 5, that's ln of 2 over 5, right? Is equal to negative 2k. How do I get k by itself? Well, all I have to do is divide by, multiply by negative 1/2, and divide by 1/2. So k equals negative 1/2 ln of 2/5. This is our k. Any questions so far? So our answer is this right here. This equation right here. But instead of writing k, I'm going to write this right here for k. And let me see if I can write it on the next slide. You guys let me know when I can continue.
Go ahead.
Okay, so I'm gonna go ahead and try to do this right here. So let me go ahead and write on the next slide. So our answer for the last question, whoops, the answer. Oh, snap, I totally forgot I put an extra slide for the work and I forgot to do it here, fudge. Okay, that's why it was so messy. 350 n, right? Equals ln. What was it? I can't remember, guys. Oh, sorry. Where am I doing? Oh, there's a copy paste option. All I'm doing is writing this right here. So minus k. I'm sorry, it's negative t, negative t times my k, and I just found my k. We just said it was what? Negative 1/2 ln 2/5. Someone help me out. Is that what it was? And then a got added, this right here, ln 250 plus ln 250. Does that match what I just wrote over here? Negative k. Okay, cool. Sorry, guys. I just had to rewrite it. Okay, let's just simplify this a little bit more. This negative right here and this negative right here. I'm gonna go ahead and combine them. That is the same thing as saying positive, right? So it's gonna be, just simplify the best you can. This is the same thing as saying ln 350 minus n equals negative times negative is positive, so it's t over 2, right? Because I'm just combining this t right here and this one I have right here. So t over 2, ln of 2 over 5 plus ln of 250. This is your differential equation. This is your answer, this right here. Okay. What is sometimes asked of you guys is to solve for n. So let's go ahead and do that. So this right here, guys, it's already looking a little tricky. How do I solve for n here if it is inside an ln? Dun, 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 our good old friend, exponential, right? Everything is gonna be raised to an e, unfortunately, right? So everything is gonna be raised to an e. Keep in mind, guys, it's not that bad. Everything's gonna simplify. You already did all the hard part, which was differentiating. So all of this is gonna simplify. E to the ln, well, that's just the inside, right? 350 minus n equals, this is the part that's difficult. But I want you to remember, guys, every time you see the plus, you can split it up as two different exponentials. And then this is multiplying e ln of 250. Every time you see a plus sign, split it up into two exponentials. And that's because of our rule. And you've been doing it on your homework every single time. am times an is m plus n. Yep. So this right here, what we're gonna go ahead and do is just simplify the best you can. Whenever you have an coefficient from the ln, or this right here becomes the exponent, and this right here is two values, right? They equal 1. All right, so we got this right here. Oops. 350 minus n. This is ELN 2/5 raised to the t over 2. And this right here is just 250, right? Hopefully you see what I see. This ln and this e are inverses, so I can get rid of them. So all I'm left with is 350 minus n equals, and I'll slow down because I think I'm going too fast, t over 2 times 250, right? We're almost done, guys. Almost done. Okay. This n is negative, right? So I want to leave it by itself. So I'm going to go ahead and move this right here to the right and all of this right here to the left, just to leave n, like I'm leaving n to the right, so it can be by itself, and then it becomes positive, and then all of this becomes negative. So it's going to be, our final answer is going to be 350 minus 2 over 5 raised to the t over 2 times 250 equals, well, the n was negative, but I moved it to the right, so it was positive now. This right here, guys, is how to solve for n. So this right here, guys, what we're actually doing is would be a free response type of a differential equation. So I know it's a lot of work, but this would be your, what our free response questions would look like. So that's why I split up into different terms, little different parts. You guys let me know when I can continue.
Sir,
Yes.
I wonder if we can multiply the 250 with the 2 over 5 despite the exponent, because that can be simplified further to be like 500 over 5, which I
Oh,
think,
good question. Good question. And keep in mind, I do see that issue coming up. But what is the exponent of 250? It's a 1, right?
yeah, one.
The exponent to the 2 or 5th is a variable divided by 2. So you cannot combine those like terms. Those are not like terms.
What?
Remember, this right here is the same thing as saying, let's see, 2/5 square root to the t. Like, these are not like terms. The same way you cannot multiply 5 times 12, right? Because 12 is not in a square root. This is not the same as saying square root of 60. This is the same thing as saying 12 square root of 5. Does that make sense, Albert?
Mm-hmm.
Yeah.
Also, say something about isn't t equals 3.
Yes, that's on the next part. Yes. But this is just how to solve for n. Oops, sorry. This is just how to solve for n. So if you wanted to model how many bears there are in 1 year, 2 years, 3 years, whatever the case may be, you could do this. So in my next equation, the next part of the question says how many bears are there in 3 years, right? So dang it, here's the part that I struggle. 350 minus my equation, whoops. Only if there was a copy paste version on this. T divided by 2, I believe, times 250 equals n. So as Joe mentioned, n is equal to 3. So all I have to do is substitute my 3 into my t, right? Because t equals 3. And I'm trying to find n. So this is 350 minus 2/5, 3/2 times 250 equals n. So this right here, guys, it is a calculated question. So I got this right here to be on my solution. I got that it was 86754 bears. The question didn't say to round, so I will keep it up to 3 decimal places right here. I should have probably not done that. But they will be more exact, just that the question that I found didn't ask me to round. Even though it doesn't make sense, how can you have 3/4 of a bear walking around, you know? So this was what I got in the calculator. So I left it to 3 decimal place, couldn't tell me round. Ideally, I would want to round up, but they didn't say anything, so this is an acceptable answer. Any questions so far?
I said something about 3/4 of a bear. Just remember, there's something called 1.7 cents.
Yeah. Okay. So what if the last question, for some bizarre reason, oops, you can't see that. For some bizarre reason, t reached infinity. So let's pretend the Earth lived forever and bears lived forever and nothing happened, to where this equation was messed with and bears just kept on living, reproducing, and doing their own thing. What would happen as as t reaches infinity? Well, keep in mind this one can be done without a calculator, and I'm gonna go ahead and show you guys how. So the equation for n, we just said, whoa, n is equal to 350 minus 2/5 t over 2, and then times 2 at 250. Well, let's think about what's happening here. As my t goes to very large numbers, right? T goes to very large numbers, let's say infinity. What's going to happen to this number right here? Infinity divided by 2. Can we still agree it's a very large number? Like, it would still be something close to infinity, right? So now I have 350 minus 2/5 raised to infinities, right? Let's say, right? It's pretty close to infinity, and times 250, sure. Now, this right here, we know whenever we do exponents to a fraction, n over m, right? And let's say x. This is the same thing as saying the numerator gets the exponent and the denominator gets the exponent. So this is the same thing as saying 2 to infinity over 5 over infinity, right? Think about it like this. My pizza, where's my mouse? My pizza is growing very large in the denominator. It's growing larger than the denominator than in the numerator. So it's gonna be, what's gonna happen to my pizza if it's growing? It's gonna be bigger in the denominator than in the numerator.
0.
Yeah, so in reality, this right here, all of this right here is gonna be 0 because this right here equals 0. So what are you left with?
N equals 350.
Yeah, n equals 350. According to this population growth, as they continue to live forever, they will only have 350 bears. Pretty cool. That's all I have for you guys. I do have a meme for you guys, but I think you guys already saw it accidentally. Sorry. Any question before I continue? It became 0 because I have 2/5, right? And if I raise both of them to infinity, this won't go to infinity faster than this number right here. So if I have a pizza and I share with a lot of people, right? My pizza will eventually become smaller and smaller slice, so where this will become 0 over 1. Does that make sense? Yes, no? If not, the calculators have an option to do the limits. I wouldn't recommend it, since if every time it's a fraction, it would give you, every time it's a fraction, it will always increase faster in the denominator. Okay, this is a meme for today. Yeah, hopefully it makes sense. The homework will be due on April 15th. the went for Wednesday. Whoops. I still don't have clear plans, but that is our NIMSY date, and it's gonna be done online. So I should be getting the video today on how that's gonna work. But ideally, they went ahead and presented the NIMSY thing on one of the idea classrooms, and I'll go ahead and share that video, and then instead of having class, I will just give you the video, you guys watch it, and then I'll be available for questions for an hour in the afternoon. So pretty much there will be they will give you a video, and then I think it's talking about graphical analysis, so the fun chart. And that's what is going to be covered in the NIMSY video. So I think they're going to happen every Wednesdays. So one per week. Okay. So I'll be uploading the video. Hopefully, if I get it today, I'll upload it tomorrow so you guys can go ahead and see it as soon as possible. And then I don't know how many questions are covering since I haven't seen the video myself. But this is great stuff for what we're going to go ahead and see. Other than that, guys, that's all I have for you unless you have questions.
Let's have a good day.
All right, guys, have a good one. For the homework, I only went ahead and made one question like when we did. So like the bear question, don't be expecting a whole bunch. It's just one. I know it takes long. It's not tough stuff. Of course, Christian here, ask me and I'll help you out. But it's not that hard. Other than that, guys, you guys are good to go. I appreciate you guys. Thank you. I'll stick around in case you need questions or answers. Bye, Joe. Bye, guys.